Hello YouTube viewers, welcome to my channel Science and Technology. In today's show, Future Friday, we're going to talk about desiccant assisted air conditioning system. So let's dive deep into it. So what exactly is the problem? Well, we can withstand a lot of high heat. Basically, if you are stuck in Dune, Arrakis, you can survive it. It's just that as long as it's not humid, meaning if you are stuck in tropical region where it's hot and humid, you're dead. Basically, there is this chart. Again, it's available in Celsius and it's also available in Fahrenheit. Basically, for example, if you have 49 degrees Celsius air temperature, that's harmful to you if your relative humidity is basically zero. So you're like, very dry air is still harmful to you, but here's the, it starts to become lethal if your humidity is only at 30% relative. And again, even at lower temperature, let's say 29 degrees Celsius, if you have zero humidity, cool, your body, like in terms of thermal performance, is like, I got this, no problem. But the moment your humidity starts to reach basically 90% relative humidity, it will start to cause an issue for you. And again, this the moment it starts to touch 50, even a minor gain in humidity starts to become lethal. Like this is yellow zone, most of them. Red zone starts to happen at 40-ish kind of degrees Celsius. The moment you start to go more than that, it's like, oof, humidity has to go down, otherwise your body basically can't maintain its core temperature because it has only one mechanism. It dumps the basically heat using sweat. Your sweat evaporates. That's why a dry hot scenario does not hurt that much, but when you have a hot environment and humid, it's very uncomfortable because your core temperature is starting to freak out. So that's the whole point. And tropical regions are worst of both. Basically, not only it's hot, it also humid. So that's a danger zone. So let that be very clear. Now, should you care about this? Well, majority of Earth's population lives here. So ta-da! If you look into population point of view, not only India is there, also China is there, and US also has some area that behaves like this. So let that be very clear. It's not like who cares, like it's Antarctica or no. Everybody cares about it, like literally one in, well, half percent. So everybody cares about it. And dehumidification, you're like, okay, let's dehumidify. It's very ludicrously energy hungry, so that's an issue. And if you think your AC bill is high, trust me, in any place that has high humidity, it would be bonkersly high. Majority of your energy bill would be not for the cooling of the air, it would be simply removing the water. It's not an efficient process. It consumes energy like there is no tomorrow, and it also has feedback loop issue. Basically, more heat you dump into the outdoor environment, the more greenhouse effect gets amplified, so to say. So fundamentally, a heat island effect gets amplified. So there is a serious problem. We have to manage humidity, otherwise this whole zone could become a very serious poof zone, meaning you are there, you poofed. Not even joking. Majority of people who are getting poofed in this sort of scenario, they are not only going when the high temperature is very high, they are also going there when high temperature gets mixed with high humidity. That's a flat out you're dead combination. So desiccant, that's the cheat code that we have figured out. Now, the reason why dehumidification is such a problematic thing is because latent heat of vaporization of water is huge. Like how huge? Well, it's you are talking about 2260 kilojoules per kilogram. That's a lot of energy you have to extract from vapor in order to convert it into liquid. So yeah, that's a lot. And in terms of other unit which you are more familiar with, you are looking at almost 0.6 unit of energy for 1 kilowatt, like kilowatt hour. So 0.6. So it's a lot of, basically your air conditioner could be running, even if it's only removing, let's say 3-4 liters of water, like 5-6 units of electricity is consumed just for that. So it's a very brutal thing. And the penalty is you have to force your AC to work harder, because instead of taking heat away from the air that's supposed to give you better cooling, it has to basically dump all that capacity, all this cooling capacity, into phase change of water. Oh, water is condensing. So its water is not getting either hot or cold. It's just like, okay, I was in this state, I've changed the phase change, I dumped all the heat that is going into the condenser, so to say. That's not recommended. You wanted air to cool down. That did not happen. So we have to basically oversize ACs for this reason also. And then you have to understand, okay, how it's any different from desiccant puppies. Now, desiccant has this one advanced thing. It absorbs moisture. It's just like takes vapor molecules. It's just like, I'll take it. It does not do phase change. It takes it, and basically it has structural components in some scenarios. Sometimes it has chemical affinity. Basically, molecules and atoms are behaving in such a way that's like, it takes it. And then there is no phase change. Basically, air went through. Basically, you had air, your air that's supposed to be processed, and its humidity got stuck into this. Basically, desiccants were like, hey, I'm going to take it. And desiccant take it. Now, here's deal. Okay, what do you do afterwards? Well, afterwards, you basically heat it up and dump it again. So, and you must have seen this sort of desiccants in your nearest transformer. Transformers many times have that desiccant box. So, if they are blue, it's good. And if they start to turn pink, it's bad. And again, they are also available in rechargeable packs. Again, all desiccants are rechargeable. It's just that common pouch that you get in your shoebox, they are only designed for single use. And again, there are other color dyes also mixed, so you can go from orange to green. I don't like this, but it's also available. But blue to pink is super cool looking, so to say. And you absorb what H2O and you dump H2O if you get heated. You do not have to do anything other than that. There is no phase change. So the total energy consumed for the amount of water removed from the system is much lower than the basically latent heat of vaporization, like exponentially lower. So in high heat and high humidity scenario, this is like shut up, take money. So what's the logic behind it? Logic is very simple. You want to dry the air before it gets to evaporator coil, aka your normal air conditioning unit. Before your air goes to it, you want to remove all the moisture if possible. So that's the whole point. And if you do that, refrigeration does not need to deal with phase change energy, meaning, oh, the water is condensing, so calculate the kilogram of the water and then calculate back how much heat was dumped into it. You don't have to worry about it. It's like, hey, air was dry. You just basically use these wheels to heat it away. There is no feature. Now, does it matter? Like, have people built it? Does it matter? Short answer, yes. Basically, in large enough units, especially in tropical places or even in American places, if there is high humidity regularly, the energy saving starts from 30%, goes up to 70%. Now, let that be very clear, 70% will only happen in certain seasons when you have ludicrously high heat with ludicrously high humidity. In case of India, that's monsoon season, almost like a 2-month season where you just have bonkers amount of humidity. So, in those sort of scenarios, you will have very large amount of heat saving, I'm saying energy savings, and even in like, short of dry environment, 30% savings. So it's a shut up, take money. We have tested it. That's the whole point. Now, how do you recharge it, right? You have a system which absorbs the moisture, cool, awesome, but you have to dump the moisture. So you have to heat it up for that. How do you get that heat? Now, this is where it's even more interesting. It does not require bonkersly high temperature. You can use waste heat from industrial processes. You can use reject heat. Reject heat as in like the air conditioner is dumping that heat. That's reject heat. That can also be used. And solar heat in case of India, if you want to really move some air, so to say. And again, let that be clear, these things are so powerful. If you have good enough heat source, it can run on native air, meaning air is coming in and you have a factory, and a factory can easily handle non-air conditioner, but it must be dry. It's like, I got this. Like hundreds of cubic meter of air can be filtered regularly without any issue, removed from moisture without any issue. If you have heat, and again, if you are running an industry, there is more than good enough chance you have more than enough waste heat. You're like, bro, don't worry about it. So, or in some scenarios, some German companies are also figured it out. It's like, hey, just use the reject heat. Don't worry about waste heat. You have reject heat from the air conditioning unit. So just do that. So that makes it exponentially energy efficient. So 30% energy savings is like you're starting. 40-50 is like, yeah, you have optimized it. So, and again, if you're running at solar, it's like even more. So that's the core logic of it. Now, let me be very clear, there are solid and liquid, and some companies are figuring out that while this does work, known, time tested, it's not that great. Specifically, the fact that it does require kind of hot temperature or a lot of surface area. Basically, if you're trying to use reject heat, you may not find it to work very effectively. So you have to have much bigger drum or rotating much slower. So trade-offs. And sometimes they generally have a heater block that heats up air to 120 or 160 degrees Celsius. Liquid ones can work at much lower temperature delta, and to make sure that liquid does not have any contamination issue, they use membranes which only allow vapor to pass. So that's the logic behind it. So what options do we have? Well, we have a lot of options. You have lithium chloride, you have calcium chloride, you have glycol, you have lithium bromide, you have silica gel, you have activated alumina, you have zeolite. You have a lot of options. Now, solid and liquid, these are generally two primary categories. Now, desiccant wheel generally is a solid puppy. Now, why we make these wheels? We can design it to have ludicrously large surface area. I mean, hundreds of square meter of surface area in a small drum. So, a lot of surface area. Now, in that surface area, it generally is made out of basically metal or ceramic. Modern ones are mostly ceramic. And you have material on top of it like silica, alumina or zeolite. That's up to you, based on your requirement, based of your basically desires output. All these three things could work, but some will give you one thing better, something will give you another thing better. So that's why all three are used. But there are others also, but be mindful, these two are the major market grabbers, so to say. And then you send it through hot air. That hot air has to be around 150 degrees Celsius. That's the penalty part of this puppy. Now again, industrial waste heat is like, bro, who cares? If you have ammonia as your refrigerant, it can easily dump that kind of heat. And if you do not have that kind of heat, but you still want to use reject heat, you can just send it through a much slower rotating drum. It will not be as efficient, but it will still work. It will not be great, but it will be good. Not great, not terrible. Now, if you really want great performance and you do not want to dump energy into the heating elements, then you can come into liquid desiccant. Now, like, okay, if we have the technology, why don't we use it? It's messy to have this system. Again, this is a design of a normal spray, almost like a desert cooler. You have a small desert cooler, you just spray desiccant, it absorbs the moisture. You take the desiccant, which is now saturated, you send it through a heater, it boils it away, basically removes the water from it, and ta-da! So you do that, but the plumbing does become messy, and some designs, because they might end up heating the liquid, you do not want a hot liquid going back into your refrigeration system. So they might be like, okay, during daytime we recharge one pack and use another pack. Like, okay, why? What's the benefit? Well, you discharge it during the daytime, cool it off during the nighttime, and next cycle you use that cool down, basically unsaturated desiccant. Then you cycle it through the indoor environment and do second package, same recharge. So to optimize, basically it's all about optimizing, because again, if it's too goddamn hot, it's not optimized well enough. But low temperature regeneration makes it super easy. And be mindful, you can, if you have insulated tanks and insulated pipings, it can be done in such a way that it does not heat up air too much. And again, removing heat from a dry air is not that hard for air conditioning. So you have generally calcium chloride. Now calcium chloride is the favorite one for liquid system, simply because it has bonkersly high capacity, meaning if you have a 1 kilogram of basically calcium chloride, this puppy can easily eat upwards of 1.4 kilograms of water. It's like more, it eats up more than it should. So this puppy is wet. You put a basically packet of this, it will become liquid. That's how badly it eats basically moisture from the air. So you have options. You have solid options, old technology, you have liquid options, messy technology, and then you have calcium chloride, which is like, I got this, fam. And you're like, you do not have to worry about what if you boil it, it becomes salt again. No, it won't, unless you have ludicrously overpowered heaters, and that's what you are doing. Because again, it does only starts to lose some water once you start to heat up. It's not like all the water vapor. It's like it's so hungry for water vapors. So, and again, it can be done continuously without any issue, and it does work. Even in open air scenarios, it can work. Like if you have a tent and you just want to dehumidify that, these puppies are like, I got this, I can handle it. Like you can't do air conditioning there, but it's like, I got this, at least I can dehumidify, which again, if your temperature is hot enough and if it's basically your relative humidity is low enough, it's not that bad for your body. Your body is like, okay, all I have to do is hydrate myself, dump the sweat energy, and if sweat is evaporating quickly from your body, it will also not feel too exhausting, so to say. So there are some good options. Now, what can we expect in the future? Well, we have to learn this fact. At this point in time, everybody knows this. World is heating up, and heat island effect is making it everything worse. So we have to reduce the total energy consumption for cooling. If we fail to do so, we are risking what we call feedback loop, meaning the more cooling we do, the hotter the outdoor heat island effect becomes, the more cooling it requires. It creates a feedback loop, we die. So we have to solve this. This is no longer like hee hee ha ha. No, it's like we gotta solve this, puppy, and now. So that's there. Now, liquid desiccant, the fact that it can work at very low temperature, why that is such a big deal? Because Indians can use it. Why Indians can use it? Because we have a lot of solar panel. Now, ironically, India's like kind of lagged behind in this core technology of PVT. Basically, you have photovoltaic plus thermal panel, meaning behind it you have a thermal panel. Now, does that give as high temperature as a like normal hot water from solar? No. But does it give you hot? Yeah, it can easily go from 15 to 20 degrees Celsius from ambient. So if ambient is 50 degrees C, you can easily get your water to like 15 degrees Celsius above that, which is more than good enough for desiccation purposes. And again, if you have a scenario where it's like, hey, I now have a liquid that is like, it's very hungry for water, but this will be 60 degrees Celsius, you let it cool overnight and you do that cycling packages. So PVT allows us to utilize just normal solar panel heat. Again, when I started to look into PVT, the main problem I always saw was like, what the hell Indians gonna do with that heat? Well, now I realize there are more than enough options. First, you can run dishwashers with hot water. Awesome. You can use basically washing machines with hot water. Awesome. Bathing, not that desirable in India, but again, some people would find it useful. And then you can dry the air. Shut up, take money. So there is a lot of use for it. And waste heat, if you have waste energy, utilize it. Why throw it away? So that's there. And let's assume you do not have the luxury or the money or the surface area needed for basically a giant PVT system which has enough electricity for solar air conditioning and PVT, desiccation. But desiccation will work. Even on a small scale, desiccation will work more than fine enough. And again, it will make unlivable condition to comfortable. Now, it won't be like great. It will be just like, it's a bit hot. Like you will survive basically as long as your body can dump heat away. It's surprisingly resilient, like surprisingly, especially if you are under a shed. Basically, if you do not have direct sunlight cooking you, your body can handle surprisingly hot air. And there is another benefit. You can use basically evaporative cooling at that point in time, because again, humidity is being drawn from a place. It's not becoming hazardous. So there is a really good scenario where we can have all this heat load that is from a building. We can reduce that power. We can use that power itself in order to, remove the water, basically cheat code the water, which again has a positive feedback loop where it's like, hey, less power is consumed and more water is removed. Everybody wins. Electricity goes down, because again, in the normal air conditioner generally have pipes, and those pipes, if it's not draining the water clearly, it starts to, dripple. And you're like, does that matter? Yes, a lot. So we have learned this the hard way, that you want to remove moisture without going through the basically phase change. And desiccant systems does have that. Now world is heating up enough where people are like, yeah, we have to save every megawatt possible. So we are looking really into it. And that liquid system is really good. If somebody can figure out how to do the membrane system cheaply, that's shut up, take money. Shut up, take money. And again, that also solves the issue of like, thermal energy going from one to another. You do not have to worry about the cooling part of that. Like basically have a desiccant that is charged, and then you want to cool it down. No, just use it directly. That will be awesome. So this is a very necessary technology for all of us to just like, okay, buildings had it, giant HVAC systems have it, cool, awesome. But everybody else also needs to get it. Otherwise, heat island effect will fry us. So this was my presentation on desiccant based boosted air conditioning system. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.